So today we are going to learn code section 4.4, which is properties of logarithms. So just like properties of exponents, we are going to learn properties of logarithms. So first one is the product property. So the product property is log of xy to the base b equal to log x to the base b plus log y to the base b. So we are going to write them as sum. The next one is the quotient property. Quotient means the division. So log of x over y to the base b. For division, we have to write two separate with subtraction. So it's going to be log x minus log y with base b. And the third property is power property. So we have log of x to the power p with base b is, you have to bring the power to the front. So it's going to be p times log x to the base b. So now we are going to see some examples how to apply these properties when you solve problems. So let's take, we have to use properties to simplify. Simplify using properties of logarithms. Okay, so the first one, we are going to see log of 2. So we have to see what property we have to apply the appropriate property for each problem here. So number one, we have log of 2xy. So since it's a multiplication, which means product, here the base is, there's no base. We know that if there is no base, the default base is 10. So we have to apply the product rule. So each one you're going to add plus log y. Okay. The next example, we are given specific base. So the first one, the base was 10. The next one, the base is 2. So it's going to be log 2. Whenever the base is given, you have to make sure you put the base. And we learn if you have the base and the number, they are same, then it's going to be 1. So the answer is 1 here, plus log x to the base 2 plus log y to the base 2. Next, ln of 3 times a plus b. So here it's multiplication, so it's going to be ln 3 plus ln of a plus b. Remember, there is no property for addition. The property is only for multiplication, division, and the powers. Next, problem number 4. Again, we are going to use the quotient property. To the base 7. So this is going to be log z. Since it's division, we have to subtract So it's going to be log z to the base 7. I can write 49 as 7 square with base 7. And remember the power property, you have to bring the 2 to the front. And we know that if these are same, it's going to be 1. So it's going to be 2 times 1, it's going to be just 2. Next, problem number 5, we have log to the base 7. So it's going to be log a to the 7 minus log 14 to the 7. We can't do any more simplification. This is our answer. Number 6, we have log 100 over x plus y. And again, remember the base is 10. If there is no base, the default number is 10. So I'm just putting the 10 just to simplify the answer. And log 100 to the base 10 is 2. You can either use your calculator or you can use the power rule. So it's going to be 2 minus log x plus y. Number 7, now we are going to use the power property. So it's going to be ln x to the power 5. You have to bring the power to the front. So it's going to be 5 times ln x. And then number 8, ln e to the 5. So the base is different here. So it's going to be ln e. We know that for ln the base is e, so which is going to be 1. So the answer is just 5. Number 9, we have cube root of x squared. So I can write this without the radical sign as x to the power 2/3. Remember the index is the denominator. So it's going to be, you bring the power to the front and then it's going to be 2/3 times log x. In number 10, we have log 5z divided by w to the base 3. So we have two rules we have to apply. The first one, for this one, we have to apply the product rule. And because it's division, we have to apply the quotient rule. So we are going to apply 2 different rules here. So how do we do? So log of 5 to the base 3, that's the product rule. So we have to add and then v to the 3. And since it's quotient, we have to subtract in the denominator. So that is the answer. So number 11, we have log AC over 5d to the base 7. You remember we have 2 properties for the numerator and for the denominator. So I'll show you. First, apply the product rule for the numerator. So that base is 7 minus log of the denominator. So I'm going to put the log 5. Okay, minus the denominator is, again, we have to apply the product rule. So it's going to be log 5. Okay, so we are applying first product rule and the division quotient rule also. Now I have to distribute the minus for both of them. So let's simplify the answer. So log A plus log C both becomes minus log 5 minus log d. So we applied both product and the quotient rule for the whole problem. So next one is number 12. We have ln of x squared times y. So we have only product rule we have to apply and the power rule as well. However, we don't have any denominator, so there is no quotient rule. And bring the 2 to the front. So it's going to be 2 ln x plus ln y. So number 13. We have ln of so it's going to be ln of x to the power 2/3 minus ln of, there is no, we cannot separate the w and z, and all we have to do is apply the power rule, bring the power to the front. So we can see number 14, we have log square root of 4x over y z to the third with 2. So we have a lot of things we have to apply. So let's first remove the power by writing as an exponent. So these are rational exponents with power 2, sorry, with base 2. So now we are going to apply the rule one by one. Okay, sorry. So we have to first bring the power to the front. So it's going to be log 4x over y z to the third with base 2. Okay, now we are going to expand that. So it's going to be, first we have to apply the product rule here and the product rule here as well. And then we apply the quotient rule as well. So it's going to be log 4 to the base 2 plus log x to the base 2 minus of log y to the base 2 plus log z to the third with base 2 and complete the bracket. So I'm going to continue here. So it's going to be 1/2. So I'm going to write log 4 to the base 2. I'm going to distribute the negative sign here. So it's going to be log y to the base 2 and bring the 3 to the front. So it's going to be 2, 2. Now next we are going to simplify a little bit. So this is going to be 2. This whole thing is going to be 2 plus log x to the base 2. I didn't distribute them. You can leave the answer like this or you can simplify. So now we can distribute the half for each one of them. So we get 1/2 times 2 is 1 plus 1/2 log x to the base 2 minus 3/2 log z to the base 2. So this is the answer. Okay, so the next one I'm going to show you how to put the logarithmic expressions into a single logarithm. So write as a single logarithm. So we are going backwards. Okay. So far we applied the property by expanding them. Now we are going to put them into one single logarithm. So if you take number 16, we have minus log x. Since it's subtraction, it's going to be quotient. So it's going to, we are going to write as one single logarithm. So it's going to be 4x minus 3. We have applying the quotient property. Next, number 17. Okay, so we have plus, that means we are going to use the product. However, let's first move the power to the front. So it's going to be log z to the base 2 plus log y to the 4 to the base 2. Now, since addition, it's going to be product rule. So it's going to be z times y to the 4 with base 2. That's how we can make 2 or 3 or 4 logarithms into one logarithm. Number 18. This is with natural logarithm. So let's see how we can do this. So whenever you have plus, they're all going to be product. So let's first move this one to the front. So it's going to be ln x to the third. So these two are going to be product. So it's going to be in the numerator. And this is going to the denominator because this is the quotient. So it's going to be ln x to the third times x minus 2. And the denominator is 5. So that is the answer. Okay. Number 19. So we have 2 plus 2/3 ln z to the 9 minus ln z. So it's kind of long problem. So first we have to distribute the 2 for each one. So 2 ln x minus 2 ln x squared plus 2/3 ln z to the 9 minus ln z. So this one goes to the numerator, x to the x squared. This goes here, so it becomes x to the 2 times 2 is 4. And then this goes here, that becomes ln z to the 6. Multiply 2/3 times 9, you will get that. So which is equal to ln x to the its product over x to the 4 so z to the 4 times z. So z gets cancelled. We get this is 1 5, so we get x squared times z ln x squared times anything. Use the exponent rules. Oh, sorry. Here it's x to the 4. So we get sorry. So it's going to be x z to the power 5 over x squared. This is the calculus. The next one, we are going to use the, we have to approximate the values. Oh, okay, let me do number 20. We have -2. We're going to use some factoring polynomials as well, so I have to want to solve this one, number 20. Okay, so this is going to be, we have to move the 2 to the power. So it's going to be negative log of x plus 5 square. And the base is 5 given here. So I have to include the, don't forget the base. And log x to the base 5. Now we are going to apply the rules. So these are product rule. So we have to multiply them. This is the quotient because we have minus. Whenever you have minus, it's going to go to the denominator. So this is product. So it's going to be x times x squared minus 25 over x plus 5 squared to the base 5. Now what we are going to do, we are going to factor the numerator and the denominator. So it's going to be x times, this is per difference of squares. So we can factor this x squared minus 25 to x plus 5 minus 5 over, and x plus 5 we can write as x plus 5 squared as x plus 5 times x plus 5. So one of the x plus 5 gets cancelled and the base is 5 here. So from here we are going to write the final answer, which is log x times x plus 5 got cancelled, and there is one more x plus 5 left in the denominator and the base is 5. So this is our final answer. Next we are going to learn how to approximate the value. So we are given, we have to use the given values. Log 2 to the base is given. And we are going to use our calculator here. Use these values to find the following values. So 21, we are going to find log of 21 to the base b. So I can write the 21 using these two numbers, 3 and we have to use only the numbers which are given. So I can break it down to 3 times 7 to the base b. So that equals, by the product rule, it's going to be log 3 plus log 7 with base b, and put the numbers. What is log 3? It's approximation. Log 3 is 0.6826 and log 7 is 1.2091. So when we add, we get 1.8917. So that is the answer for this problem. So we're going to use the values that are given for us. And the number 22, we have to find log 9 to the base b. I can write this one as log 3 squared to the base b. Then you move the 2 to the front. And you can write log 3 to the base b is 0.6826. So the answer is going to be 1.3652. Okay, and a couple of more problems. And number 23, sorry, you can try number 23, so I'm going to leave it to you. I'm going to do the change of base formula. So the change of base formula is given by log x to the base b is going to be log x over log b. So the base b becomes 10 base here, or you can change any base, any different bases, but they have to be equal. Or you can also say it's going to be ln x over ln b. For ln, you cannot put any base because the base is always going to be e. So let's use we're going to use change of base formula for the following problems. And we are going to approximate to 4 decimal places. So log 15 to the base 7, you enter on your calculator. You can use your calculator, you can put any base, that's fine as well. It's going to give you this number, 1.317. And number 25 is log 0.3 to the base 5 is log 0.3 divided by log 5, and then you can enter on your calculator again. So it's going to be 0.7481. So this is the end of section 4.4. So I will see you next time.